wide variety of concrete types and masonry materials is in common use on today's building site. Each has its own peculiarities as a base for fasteners. Concrete is an ideal material onto which timber, steel and other materials can be attached. Properly mixed and placed concrete is uniform in consistency and strength throughout, allowing a fastener to be placed almost anywhere in the mass. In most cases, the only problem in fastening to concrete is ensuring that the fastener can be located to avoid the reinforcing steel. Masonry materials vary considerably. Some provide strong, secure fastening, whilst others can carry only light loads due to the low strength or design of the particular material. Bricks and concrete blocks could have either a solid or hollow center. Most bricks have holes through the thickness of the brick, replacing what was known as the frog of old-style bricks. The holes act as a key, allowing the mortar to flow into them, forming a strong bond between courses. Concrete blocks are usually hollow, saving weight and the amount of material used to make the block and providing some degree of protection from the passage of water through the block. The load which can be applied to a fastener in hollow brick or block may not depend on the strength of the fastener, but on the point at which the block disintegrates or pulls out of the wall. Natural stone comes in an almost endless variety, both in composition and strength. The success of fastening into stone will depend on the type of stone and also on the way in which the stonemason lays it. Other masonry materials in common use are lightweight aerated concrete and gypsum plasterboard. Special care needs to be exercised in choosing the correct fastener for aerated concrete, but as it is uniform in consistency and relatively solid, a secure, dependable fixing can usually be made. Let's look now at why a masonry anchor would be chosen in preference to a powder-actuated fastener for fixing onto masonry materials. Masonry anchors in the larger sizes are able to support heavier loads. They are available in a wider range of sizes, and no special training is required to use them. Masonry anchors can be divided into two specific groups: mechanical anchors and chemical anchors. Within each of these groups, the load-carrying capacity can be further divided into heavy-duty, medium-duty, and light-duty anchors. The load-carrying capacity of an anchor will depend on several factors: the strength of the concrete or masonry, the location of the anchor, and the depth at which the anchor is embedded. When an anchor in solid masonry is subjected to a tensile load, part of the load is transmitted to the substrate as a compression load and part as a shear load. This results in failure of the masonry in the shape of a cone being pulled out of the masonry surface. In general, this cone increases in size with any increase in the depth of embedment of the anchor. The increase in embedment therefore results in an increase in holding power up to the load-carrying capacity of the anchor, after which the bolt may snap under tensile load. If anchors are located too close together or near to an edge, this coning effect works to diminish holding power. With expansion-type mechanical masonry anchors, edge distance is especially important to load capacity, as the expansion of the anchor itself places a load on the surrounding masonry, tending to break away the edge. This problem is accentuated with multiple expansion anchors placed in line along an edge. In close-edge situations, it may be necessary to use an alternative Ramset Masonry anchor, which does not place stress on the surrounding material. In hollow masonry materials, the tensile load capacity is dependent on the shear load capability of the thin section of brick or block. The objective in hollow materials is to spread the load over as great an area as possible to increase the load potential of the fastening. Ramset masonry anchors are available to cover almost every anchoring problem. To choose the particular anchor suitable for any specific task, a simple selection sequence should be followed. First step is to determine the load which the anchor will be required to hold. Once the general load requirement is determined, next decide the environmental conditions.